students. So today I am going to discuss the remaining chemical properties of alcohol involving CO cleavage, and today here your completely alcohol chapter is alcohol part is over. Okay, in the remaining portion, if it is there, it will be there, then it is not important, but today all the important topics has been covered. So see here today you can make a heading. First topic I will go, that is dehydration of alcohol. Dehydration of alcohol. Now see here dehydration meaning, now we are very well versed with the chemistry terms, so we know that dehydration is removal of H2O. Nothing but what? Dehydration is nothing but what? Removal of H2O. Second, now we have to remove H2O. So someone reagent should be there. Some reagent should be there who will help us to remove this H2O. So that reagent is sulfuric acid. Concentrated sulfuric acid will help, or concentrated H3PO4 will help. So H2SO4 or H3PO4 will act as dehydrating agent. Dehydrating agent. Clear? Second point. Now see here. See, as we know here, if I am taking one alcohol, say ROH, and I am reacting with this acid as H plus, okay, so what will happen? This H plus will react with this RO, this H plus will react with this OH, so here cleavage will take place is of RO cleavage. Here cleavage will take place of RO cleavage, that is CO cleavage will take place, and there will be a formation of here cation. Clear? So first, that dehydration is an example of CO cleavage. Clear? Is an example of an CO cleavage. That's why I am teaching you the dehydration of alcohol under the CO cleavage. You can see here there is an H plus and there is an OH minus, there will be OH. So this H plus will attract this OH, okay, and this OH will react with this H and forms H2O, and the formation of R plus will take place. So first point here, it is observed that there will be a cleavage of here RO, that is here cleavage will be of CO cleavage will be takes place. Here the cleavage will be of CO cleavage. So it is a dehydration is an example of CO cleavage. Point number one. Point number two. See, here I have to remove this OH. Here I have to remove this OH. Yes or no? And you know, student, OH is not a good living group. Last class also I have explained you that OH is not a good living group. So what to do here? So first point. See, I am teaching you here. If you understand this, my all the points, you can understand easily the mechanism. So I am telling one by one. First I told dehydration is the removal of water. Who will help us to remove the water? Concentrated sulfuric acid or concentrated H3PO4 will act as a dehydrating agent. They will act as a dehydrating agent. So there is a removal of waters in the presence of H plus. This H plus is either provided by H2SO4 or this H plus is either provided by H3PO4. Now this H plus will react with this OH. So it will form water, means the cleavage should be between R and O. This R is nothing but what? C. So your cleavage should be CO cleavage. So dehydration is an example of which? CO cleavage. Dehydration is an example of CO cleavage. Clear this part? So dehydration is an example. Now you know that OH is not a good living group. So when you know that when OH is not a good living group according to the experiment, so what we are doing? We are doing the protonation. So here protonation is compulsory. So that's why protonation is done. That's why protonation is done. And then after protonation, we will follow the mechanism. Next, there will be formation of cation. Yes or no? The first point is this: OH is not a good living group. That's why in the mechanism, what we are doing? We are doing protonation is done. Sorry, protonation is done. Okay. Second, there is a formation of a carbocation. There is a formation of carbocation. You know either 3, if R is of 3 degree or R can be of 2 degree or R can be of 1 degree. So we know that 3 degree carbocation is more stable than 2 degree than 1 degree. Okay, so this 3 degree carbocation is more stable. Yes or no? So hence the dehydration will be fast in what? 3 degree, then 2 degree, then 1 degree. So this is also a series of a dehydration of alcohol. Dehydration of alcohol means 3 degree alcohol will undergo very fast dehydration, then 2 degree, then 1 degree. Means from this, why? Because 3 degree carbocation is more stable. So when there will be formation of 3 degree carbocation, so easily it will because see here they wants to form R plus. Here this ROH wants to form R plus. So there is a formation of R plus. Now you tell me student, who can form easily R plus? One who is more stable or one who is least stable? As we know the 3 degree wants to be stable because 3 degree is stable carbocation. So when 3 degree is stable carbocation means it will be easily formed. And whereas 1 degree carbocation is not stable because least stable 1 degree. So there will be difficult to remove OH from 1 degree because 1 degree carbocation is difficult to form. That's why there will be removal of OH will be very difficult from 1 degree alcohol. So some condition will be required, then 2 degree, then 3 degree. R plus if it is a 3 degree carbocation, so 3 degree carbocation is formed, it's very easily formed. Why the formation of 3 degree carbocation is easily formed? Because 3 degree carbocation is more stable. So when 3 degree carbocation is more stable, the formation of 3 degree carbocation is also very easy. So when the formation of 3 degree carbocation is also very easy, that indicates that the dehydration will be easily seen in 3 degree rather than 1 degree. Means 1 degree also will undergo dehydration, 2 degree will also undergo dehydration, 3 degree also will undergo dehydration. But 1 degree will go with difficult, whereas 3 degree alcohol will go very easily. When 1 degree alcohol, if you want to do the dehydration, you have to supply certain conditions like temperature and concentrated sulfuric acid. But when you go to the 3 degree, that condition which you are supplying in the 1 degree alcohol, that condition which you are applying in the 1 degree, when you come to the 3 degree alcohol, that condition will get reduced. Instead of concentrated sulfuric acid in 3 degree, if you apply only 20% sulfuric acid also, your work will be done. If you don't supply temperature also, your work will be done. Clear this part? So that's why this is the series. This is very important, okay? That who will show easily dehydration? 3 degree carbocation will easily show the dehydration, then 2 degree, then 1 degree, because 3 degree carbocation is more stable. So when 3 degree alcohol is undergoing dehydration, the reaction will be very fast, because in the formation of a dehydration there is a formation of a carbocation, and 3 degree carbocation is more stable, so easily can be generated. Means dehydration will be very fast in 3 degree, then in 2 degree, then in 1 degree. So 1 degree dehydration will be done, but it will be very, very difficult. So you have to supply number of conditions, whereas 3 degree alcohol dehydration also will be done, but it will be done very easy. So we have to not to supply that much conditions, the condition which are supplying in the 1 degree. Clear this part? Clear? Understood this? So this is the main logic here. Now I will try to, first we will do certain 2-3 examples, then we will do the mechanism. Point number 1, 2, 3, 4, 5. Point number 6. See how dehydration means what? Removal of water. So how the water will be removed? So water will be removed, you see here. How to remove the water? So OH, H from alpha carbon, H from beta carbon to H from beta carbon and OH of alcohol combine to form water. In this way water is forming. How the water is forming? H will be from beta carbon. I will say what do you mean beta carbon? OH containing carbon is alpha carbon. After that beta, then gamma. That you know, okay? General organic chemistry. So H will come from beta carbon and OH from alcohol. OH of alcohol and H from beta carbon. You combine this together to form about water, and the formation will be of generated. Now we will see what will happen when I will do the reaction. See here. If I take 1 degree alcohol, suppose here. This is OH, this is H, this is H. If you remember this logic, This logic you can easily, if this OH can I write here also, OH, H. Now it is a 1 degree alcohol. So when 1 degree alcohol, see the condition. First condition is either you use concentrated H2SO4 or you can use concentrated H3PO4, and some temperature is also required, and temperature is nearly 443 Kelvin. Okay. So in the presence of H2SO4 or H3PO4, this will undergo dehydration. Now how to do the dehydration? First, H from beta carbon. Now see, what do you mean by alpha carbon, beta carbon? OH containing carbon is alpha carbon, then beta, then gamma, or so on. Okay. So OH containing carbon is alpha carbon, then another is beta, then gamma. Then clear this part? So he is telling H from beta carbon. So you take this H, okay, you take this H and OH of alcohol. So this OH of alcohol, these two will combine together. These two will combine together to form a what? Water. To form a what? Water. Now remaining is what? Write down here. C, H here, C, H here, and H here. Because this OH is also gone, then this H is also gone, so H2O. Now what is the valency of carbon? The valency of carbon should be 4. So valency of carbon is 1, 2, 3. Here also 1, 2, 3. But valency of carbon should be 4. So you make here double bond. Because this H and this OH will go, so they two will combine to form a bond. So in short, 1 degree alcohol will form the alkene. So here ethene is generated. This is nothing but your dehydration of alcohol. This is the trick to remember, that H from beta carbon and OH of the alcohol combine together to form a water, and remaining product is nothing but the product obtained during the dehydration of alcohol. Clear? Now see here. If I go with the 2 degree, so OH containing carbon is attached to another 2 carbon. So here CH, I write down here like this. Here H, here H, here H, here H, here H, here H. Clear? Clear this part? Now see, OH containing carbon is alpha carbon. Either you can say this as a beta carbon or this as a beta carbon. I will say this as a beta carbon. You can remove from H here also, or you can remove H from here also, not an issue. If you say this beta carbon, then remove H from here. If you say this beta carbon, remove H from here. Now it is a 2 degree alcohol. Now it is a 2 degree alcohol. We know that 2 degree alcohol is more stable than 1 degree alcohol. So there will be easily formation of 2 degree carbocation during the reaction. So when there is a easy formation of 2 degree, then 1 degree carbocation, so here condition will reduce. Now what the condition will reduce? Here concentrated H2SO4 you are using, instead you will use here 80% sulfuric acid only. Instead of concentrated, what you are using? 80% sulfuric acid you are using. Here we are supplying 443, here we will supply nearly 440 Kelvin. So bit temperature will also reduce, and the type of the sulfuric acid also used. See here you are using highly concentrated sulfuric acid. Here if you supply 80% also, dehydration will take place. Now what will happen? H from beta carbon, so this is H from beta carbon, this H from beta carbon, this H from beta carbon, and OH from alcohol. So this is OH from alcohol. They two will combine together to form a water. So we will see the remaining portion. So C, H, H, H here, here C, here H, here C, here H, here H. Now see this carbon valency. The carbon valency is this is 1, 2, 3, 4. Not an issue. See this carbon valency 1, 2, 3. Mean one more valency is required here. Here also you see 1, 2, 3. One more valency. So when H will go, OH will go. So one electron here, one electron here. They two will combine to form a bond, because 2 electrons form a 1 bond. So here bond will be formed. So we will generate here what? Alkene. What is this? Propene. Propene will be generated. Clear? Now see here. You compare, in 1 degree alcohol we were required concentrated sulfuric acid. But when we come to the 2 degree alcohol, this condition reduced. Why this condition reduced? Here we are supplying concentrated sulfuric acid, then only work was done. Means your power was more. Means it was difficult to remove this OH, because it is formation of 1 degree carbocation, and 1 degree carbocation is least stable. So when it is least stable, means you have to supply the harsh conditions. Now I will come to the 3 degree alcohol. In 3 degree alcohol, we are formation 3 degree carbocation, and 3 degree carbocation is more stable, so easily will be formed. When easily will be formed, so you have to supply very least condition. What is the condition? See, check it out here. See, OH containing carbon is associated to another 3 carbon. It is nothing but your Clear? Okay. So here just you supply 20% sulfuric acid also, your work will be done. If you supply 20% sulfuric also, your work will be done, and here you supply nearly 350 Kelvin. Okay. Now what will happen? See, OH containing carbon is a alpha carbon. Either you can say this as a beta carbon, or this as beta carbon, or this as beta carbon. Depends on you. Whichever you say as a beta carbon. Okay, I will say this as a beta carbon. So what will happen? H from beta carbon. So from here one H. So instead of CH3, I will write down here CH2 and H. CH2 and here H. So H from beta carbon, H from beta carbon, and OH from alcohol. So this is OH from alcohol. Will combine together to form a water. So your water will be generated. Now we will see what will happen. CH3, C here, CH3 here CH2. Okay. Now see here, this carbon valence is 1, 1, 2, 3. One more valence is there. So here one electron will be generated. Here one electron. They two electrons combine together to form a single bond. So here alkene will be generated. So 2-methyl propene. 2-methyl 1, 2, 3. 2-methyl methane ethane prop 1-ene. Okay. So in this way alkene is generated. Now you see here, if you see the condition from 1 degree to 3 degree alcohol, this is 3 degree alcohol. If you see the condition from 1 degree to 3 degree alcohol, it is clearly seen that slowly the condition which you are supplying, it is getting reduced. See, in 1 degree alcohol we are supplying concentrated sulfuric acid. When you come to the 3 degree alcohol, we are just supplying only 20% sulfuric acid, or I can say according to practical cases less than that also. If you supply 15 to 17% also, your answer will come. Dehydration will take place. Why is it so? When you are coming from 1 degree to 3 degree alcohol, here there is a formation of 3 degree carbocation, because you can see here there is a cleavage of CO. Everywhere you can see the cleavage of CO. So when cleavage of CO will take place, 3 degree carbocation will be generated here in 3 degree alcohol. So 3 degree carbocation is more stable, means he wants to form as soon as possible, easily can be generated. When 3 degree carbocation can easily be generated, so with lesser condition also dehydration will take place. That's why 3 degree alcohol will easily show the dehydration, then 2 degree, then 1 degree. So this is very important. 3 degree alcohol will undergo dehydration very easily, then 2 degree, then 1 degree. So why? Question will come on this too. Why 3 degree alcohol will show easily dehydration? Because there is a formation of a 3 degree carbocation, and 3 degree carbocation is more stable. Hence that 3 degree alcohol will show easily dehydration, whereas 1 degree alcohol will generate 1 degree carbocation, and 1 degree carbocation is least stable. Due to this reason 1 degree carbocation will not, 1 degree alcohol will not undergo easily dehydration. There are certain harsh conditions should be supplied. So you take a screenshot here. After taking a screenshot, we will go with the mechanism. When you see the mechanism, you can easily understand. Take a screenshot. So hello student. So now we will discuss about the mechanism of dehydration of alcohol. So make a note. Mechanism of dehydration of alcohol. Clear? See, mechanism is very simple, and mechanism is according to the mechanism we have done in the previous sections. Okay. So make a note first. See, if I take one alcohol, suppose if I take one example, CH3, CH2OH. This is one alcohol. Instead of CH3, I will write down here CH2 and I write down here H. Why, sir? You will understand in the present section. Now see here. This is alcohols, I have to show here lone pair. Okay. Now we know that dehydration. Who is doing the dehydration? Dehydration is done by the acid. So here H plus will come. Now remember one thing here. See, remember one thing, this H plus will act as a catalyst. Here H plus is acting as a catalyst, means in the presence of this H plus, alcohol will undergo dehydration. So this H plus is acting as a catalyst, and catalyst role is what? Catalysts are the substance, one which only help to do the reaction, which will not involve in the reaction. This indicates this H plus will do the reaction, and in the final step after the formation of the product, we should get back the H plus. So this is very important point. Now see here. This H plus is having how many electrons? 0 electron, and here oxygen is having 2 lone pair. So out of 2 lone pair, 1 lone pair will be donated to this H, and the bond will take place here. So you will get the answer here CH2, here will be H, here will be CH2. This out of 2 lone pair, 1 lone pair has been donated to this H. So the formation will occur here H, and here there will be H, and here there is 1 lone pair. Why there is a 1 lone pair here? Out of 2 lone pair, 1 lone pair will be given to the H. Now you know one who gives the electron will create what? Positive charge. So here oxygen will create positive charge. So this is my first step of the mechanism. Clear? This is known as a ethyl oxonium ion. If you want to remember the name, you can remember ethyl oxonium ion. Now student, same story, you know this. This is an oxygen, and oxygen is an electronegative element. So when on any electronegative element, if positive charge comes, so this will be highly unstable. So this unstable species wants to gain the stability. So what he will do? He will start to gain the electron from the nearing carbon. So this oxygen wants to be in negative charge. This oxygen, this plus on this oxygen indicate what? That oxygen is in a need of electron. So this oxygen will start to attract the electron from this nearing carbon. So this is the nearing carbon. So this CH2 will give its electron to this oxygen, and it will free this oxygen. So what will be generated? Now see here. So here generation will be, see this. These all are the reversible reaction. Okay, so generation will be here. This oxygen will release as H2O. Yes or no? Because see this oxygen, there was one H, there was one H. There was one lone pair here, and this one lone pair will be taken by this CH2, so one lone pair is coming here. Now see, the oxygen has a capacity to make a 2 bond. There is a 2 bond and there is a 2 lone pair. So now no charge will come on the oxygen. This is a formation of what? This is nothing but water, H2O, and there will be generation of what here? CH2, CH, and here now this carbon has given the electron. The one who gives the electron creates what? Positive charge. So as per the previous topic, I told there will be a generation of a carbocation. You can see here there is a generation of a carbocation here. Clear this part? Now this reaction what you are doing, this will be very fast reaction, because you know this is nothing but a protonation, and as per I have explained in the CO cleavage example, or in the mechanism of CO cleavage, we know that protonation is a very fast reaction, whereas the removal of water, this reaction is a slow step reaction. This is a slow reaction. When any reaction is a slow, that reaction will be rate determining step reaction. So this reaction, this step is a rate determining step. Okay, so this reaction is nothing but a what? Rate determining step. Now here there is a formation of 1 degree carbocation. Now as per the student understand, 3 degree carbocation is more stable, then 2 degree, then 1 degree, means 1 degree carbocation is the least stable. So there is a formation of 1 degree carbocation. So here the 1 degree carbocation, if it is forming, it will be, the reaction will be very, very slow, because 1 degree carbocation generation is very, very difficult, because 1 degree carbocation is least stable. When 1 degree carbocation is least stable, so the removal of water from this species will not be easy. That's why 1 degree carbocation, if it is generated, the reaction will be very, very slow. Instead of 1 degree carbocation, if the reaction was 3 degree carbocation, if here this alkyl chain was 3 degree carbocation, then the removal of water was very, very easy, and the removal of water was very, very easy. So reaction was very fast as compared to 1 degree carbocation. So 1 degree carbocation, here reaction will be very slow. If the reaction is very slow here, then in the final step what we are doing? Now see here. See, this CH2 plus needs the electron. So what will happen? This H will remove as H plus. Okay, so this remove as a H plus, and here bond will be shifted. So what will get? You will get here CH2, here CH2, and one bond will come here, so it will form as a alkene. Now see here, in the initial step, what we obtain? We have taken this H plus as a catalyst. In the final step, we obtain again back the catalyst. So here H plus will be generated. This H plus again fed back to this reaction. Another part, this H plus will react with another alcohol, and the reaction will get continue. This H plus will react with another unit of alcohol, and the reaction will get continue. So this is a protonation portion. This protonation reaction is very fast, and there will be formation of here one unstable species, say oxonium ion. Now this oxygen is having a plus charge, but oxygen is an electronegative element, so they require the electron due to this plus. So oxygen will start to attract the electron. If there is a 1 degree alcohol, it will be very difficult to attract the electron, so reaction will slow. 2 degree reaction bit fast, 3 degree reaction will be very fast. So this is the rate determining step. Here depends which type of reaction will occur. If they have 3 degree alcohol, the reaction will be very slow, very fast. Here also reaction is fast. If here it was 3 degree alcohol, 3 degree if it is there, so when 3 degrees, so this reaction instead of slow, it will be fast. So when 3 degrees, this also fast, this is also very fast. That's why dehydration will take place very easily if it is a 3 degree alcohol. If it is a 2 degree alcohol, if it is a 1 degree alcohol, this reaction will be slow. When this reaction is slow, so this reaction is fast, but this reaction is slow. Due to this, it is difficult to remove the water from 1 degree alcohol. Hence the reaction will be very slow for dehydration of 1 degree. So what is the series? So ease of dehydration of ROH series is 3 degree will be show very fast, then 2 degree, then 1 degree. Why? Because in 3 degree alcohol will show very fast because there will be a generation of 3 degree carbocation, and 3 degree carbocation is more stable. So this reaction instead of slow it will be fast. So when this reaction is fast, this reaction is fast only. So sudden alkene will be generated. But if it is a 1 degree alcohol, so this reaction will be very slow. When this reaction is very slow, so it will be very difficult to remove the water. Hence 1 degree will show very least dehydration than the 3 degree. That's why in 1 degree we are supplying number of conditions like H2SO4, highly concentrated H2SO4, some temperature also is required. Now point number 2, this H plus, this H2SO4 will act as a catalyst. How we came to know? See, this H plus is involving in the reaction, but in the final step again I got back the H plus. When I am getting again the back H plus, so I got to know that the H plus will only involve in the reaction but does not include in the reaction. Again in the final step I am getting back the H plus which I have inserted the H plus in the first step. So this H plus is acting as a catalyst. So this is the mechanism of a dehydration of alcohol. First step, protonation. Yes or no? First step, protonation. One thing more, you can see from here to here. You can see from here to here. Here there was OH, but here there is no OH. So I have removed OH from what? This CH2 only. No? See, this is CH2, this is CH2. So I have removed this OH from this CH2 only. Means I have done the cleavage of what? I have done the cleavage of CO only. So this is an example of cleavage of CO also. So in CO, you know, SN mechanism we are doing, the SN mechanism. In first we are doing what? First we are doing the protonation, then only we are undergoing SN reaction. Why protonation is required? Because this OH is not a good leaving group. When this OH is not good leaving group, I have to do the protonation. Means this OH will not leave this. I told you that story also. This OH will not leave this. So what he is thinking, let this OH will combine with some other. So this oxygen is combining with this H plus and converting into unstable species. So it will be automatically will be removed. Now he is free. So he is free means the carbocation will be generated. If 3 degree carbocation easily will be generated, then 2 degree, then 1 degree. Now this 2 degree carbocation, it will start to attract the electron from this nearing carbon, that is beta carbon. Yes or no? So it will start to attract the electron from nearing carbon, the nearing hydrogen of the carbon, that is beta carbon, because it is requirement of an electron. So this H will give its electron remove as a H plus. This removal of H plus here proves that whatever H plus we have added during the reaction again getting back after the reaction, that indicates this H plus is acting as a catalyst. So this is a mechanism of a dehydration of alcohol. And here generation of 1 degree carbocation. If I use here 3 degree, so there will be generation of 3 degree carbocation. 3 degree carbocation is more stable. So instead of reaction slow, it will be very fast. So this reaction will be fast for 3 degree. This reaction is fast only. So that indicates that 3 degree alcohol, if it is used, the dehydration will be done very easy than that of a 1 degree. So this is a series of dehydration of alcohol. 3 degree will be very easily done, then 2 degree, then 1 degree. Take a screenshot. Then I will move to the next topic, that is the remaining chemical reaction of alcohol. That is very easy. Okay, there is a dehydrogenation we will do, and reduction, and 2-3 more are there that I will do it. So today your alcohol chapter will get over. Only alcohol, not phenol. So hello students. So today we are going to see the last portion of an alcohol. So you can make a heading, okay, remaining chemical properties or chemical reaction of alcohol. Clear? Okay. So in that first is dehydrogenation. Dehydrogenation of alcohol. See students, dehydrogenation means what? Removal of an hydrogen. Yes or no? Dehydrogenation means what? Dehydrogenation indicates what? Removal of hydrogen. Now you know that removal of hydrogen means what? Adding of oxygen, or removal of hydrogen is known as an oxidation. So removal of hydrogen is nothing but is oxidation only, no? So in short, dehydrogenation is also nothing but an oxidation of alcohol only. See, dehydrogenation means what? Removal of hydrogen. So remember the redox reaction definition. Adding of oxygen or removal of hydrogen is known as an oxidation reaction. So here dehydrogenation of an alcohol is nothing but an oxidation. So we are studying what? Oxidation reaction of alcohol, which we have studied in the last section. But there we have seen that during the PCC, I was using one reagent as PCC or chromic acid. So there we seen that we are not, it is not possible for 3 degree alcohol, but here something different is there. So this is a very important, so please check it out here and understand this logic also. Okay. Point number 2, here we are using the reagent or reagent as hot copper, reagent as hot copper, red hot copper. Okay. So whenever you see any alcohol and with that alcohol if you see red hot copper, so understand this is an example or this is a reaction of a dehydrogenation, and here there are no mechanism to be studied, just to do the reaction you will understand the logic. See, first example I will take. If I take 1 degree alcohol, if I take 1 degree alcohol and when I do the oxidation, but in the presence of what? Not in the presence of PCC or chromic acid, in the presence of red hot copper, or only hot copper also you can write down, hot copper. Okay, so I will obtain here aldehyde. What will obtain here? Aldehyde. How? See, check it out. So why obtain here oxidation? This is a dehydrogenation. Arey beta, removal of hydrogen. Removal of an hydrogen means what? Oxidation. That's why I have shown the symbol of here oxidation, so that you can see the, you can get the exact answer. So see here, CH3, CH2OH. So here what will happen? Here there will be OH. There is oxidation. Why oxidation? Or I can write down here dehydrogenation also, and you can write down here hot copper. Now this H, see, same reaction which are done in the alcohol. This H and this H and this O will form what? H2O. So the remaining is what? Remaining is CH3, here C and here H and here O. But you know that carbon can never be a single bond with oxygen, it should be a double bond only to COH. So this is something but what? Aldehyde only, no? CH3, CHO. In this way, do the reaction. Clear? Hot copper. There we are using PCC. So answer remains same for PCC and hot copper for 1 degree and 2 degree. But for 3 degree the PCC does not occur. But here will occur. What will occur? We will see. That's why it's important. Second, if I take 2 degree alcohol, and I do the dehydrogenation, or see here also dehydrogenation only taking place, no, removal of hydrogen. See here, I am just removing the hydrogen only, no. So removal of hydrogen, dehydrogenation, or removal of hydrogen is also oxidation. So here also I am removing the hydrogen only, no. So I am doing what? Dehydrogenation only I am doing. And dehydrogenation is nothing but what? Oxidation only. But here we are using hot copper. There we are used to use PCC or chromic acid. See here, 2 degree alcohol will be converted into ketone. We will check it out here. How? So see, this is 2 degree alcohol. OH containing carbon is associated with another 2 carbon. So here H3, here H3 and here H. Clear? And we are doing here oxidation. Here we are doing oxidation in the presence of what? Hot copper. Okay, hot copper. If you don't write down also it will work, but if you write down also it's okay, no problem. So here H and here O. What will happen? It will get here H2O and here CH3, here C, here CH3 and O. But you know that carbon can never be a single bond with oxygen, it should be a double bond. So it will generate what? Ketone, dimethyl ketone. Here, okay, propanol or methanol, ethanol. Clear this part? We will see 3 degree alcohol. So in 3 degree alcohol, what was happening? In 3 degree alcohol, when you do the hot copper, so here oxidation will not occur, I know, but when you use the hot copper, so instead of any other compound, it will generate here. If you use here instead, see if I do here oxidation, see here student, understand this logic. So this is very very important, and in short you have to mug it up. So if I do here oxidation, if I write down here PCC, or if I write down here H2CrO4, if I write down this reagent, so answer will be no reaction. Clear? But if I write down instead of PCC, if I write down here hot copper, yes, reaction will occur. What will be generated? It will be generated here alkene. What will be generated here? Alkene. How alkene is generated? We will see this. Clear? And you can see here one thing more. See, everywhere here H2O is removed. Means H2O is removed means what? Here everywhere dehydration is also taking place. Yes or no? So instead of here also dehydration will take place. But if I write down here PCC, or if I write down here H2CrO4 for 3-degree alcohol, no reaction. But if it is written in the question hot copper, reaction will takes place. Understand? Clear? If you write down here oxidation or don't write down, it's well and good. Understood why oxidation is coming? Dehydrogenation, removal of hydrogen is oxidation. Now we will see 3-degree alcohol. So see, OH containing carbon is associated to another 3 carbon. If I use here hot copper, and heat, and that is nothing but dehydrogenation means what? Oxidation only, no? So this out of this CH3, last class, just now only I have seen, no? Last class we have seen the topic, this H and this O will form what? H2O. And what will be generated here? Sorry, here ketone will not be generated. What will happen here? Hot copper will be there. So here OH and here H. So these two will be removed and water will be generated. And here CH3, here CH3, here CH2 and double bond CH2, CMS. So this will be generated. So please remember, if you don't write down here oxidation also, you have to understand this. Okay. Don't write down, it is better because it is not given in your book. That's why I am not writing it. Okay. What you have to understand, that dehydrogenation means removal of hydrogen, means nothing but we are doing oxidation only. We are doing what? Oxidation only we are doing this. Clear? See, here there is a removal of an hydrogen only, no? H and oxidation O, H2O, remove this. Yes or no? Removal of hydrogen, dehydrogenation. Here also there is a removal of hydrogen only, no? But in what manner? Instead of dehydrogenation, here doing what? Dehydration. But there is a removal of hydrogen also, no? That's why I am telling that dehydrogenation of 3-degree alcohol will takes place. How it will takes place? It will generate alkene. Whereas 1 degree will generate aldehyde, 2 degree will generate ketone, but 3-degree alcohol will generate alkene. So you have to remember, this is only in presence of hot copper. Instead, if I add down here PCC, aldehyde, PCC, ketone, PCC, no reaction. So this you have to remember. That's it. Clear this part? Clear? So next topic I will go with the reduction of alcohol. Take a screenshot, then we will go with the reduction of alcohol. No mechanism. Okay? Okay, no mechanism for dehydrogenation. There is another topic, reduction, again no mechanism, and ammonification, again no mechanism. Just remember the reaction. So next you can write down remaining chemical reaction of alcohol. Next you can write down what I told just now. I told reduction of alcohol. Reduction of alcohol. This you have to remember. See, whenever you see red phosphorus plus Hi plus heat with alcohol, then understand this is an example of this is nothing but reduction of alcohol. So which reagents are used in the reduction of alcohol? Red phosphorus, Hi and heat. If you see with alcohol, understand you have to do the reduction. Now how to do the reduction? It's very simple. No mechanism, direct answer you will get. Okay, but just make up your mind. Understand, if you see alcohol, red phosphorus, Hi and heat, these 4 things you see, understand it is a reduction. You have to give the answer of reduction, and this has been asked many times in the competition exam also. So understand, no mechanism, just answer we need to get. Okay, what we should have? We should have alcohol, we should have a red phosphorus, we should have a heat, and we should have a Hi. If you have these 4 things, you can get the easily answer. See, I will take one example. CH3OH. Okay, it is reacted with this Hi. How many moles of Hi? You take always 2 moles of Hi. Understand. 2 moles of Hi in the presence of red phosphorus as catalyst. Okay, heating, hot red phosphorus. Okay, so this is nothing but, see, this is an alcohol, Hi, red phosphorus and heat. If you see this is nothing but what? Reduction of alcohol. Now how to get the answer? It's very simple. See, these 2 Hi I will separate in this form. Hi. Any doubt? These 2 Hi I will separate in this form. Hi and Hi. Now what will happen? This I will convert to I2. Okay. This H, and this O will form what? H plus H, H2O. So now student, remaining is what? The remaining is CH3 and 1 H. What will I get? I will get CH4. So this will be your answer. In this way you have to remember. Clear this part? Clear this part? Okay, next we will see OH containing carbon associated another 2 carbon. 3 degree you can do it at home. Okay. Again I am taking 2HI. Okay. Red phosphorus as catalyst. Okay. And heat. So see, we have alcohol, you have HI, you have phosphorus, and you have a heat. So understand this logic. Split this HI, here also HI. So this I and this I will be converted into I2, means iodine will be generated. This H and this H and this O will be forming what? H2O. And what is there? You will get here CH3, CH and H, CH2, CH3, CH2, CH3. So here also you generate methane, that is alkane. Here also you generate propane, you generate here alkane. Here also alkane, here also alkane. Respective name you can give, methane, ethane, propane. So this is nothing but a reduction. So how we came from this reduction? See, if you see the carbon, see that I will explain this, you will understand automatically. See this carbon oxidation number. If you see this carbon oxidation number CH3OH means what? I can split it in this way also, no? CH3 plus and OH minus, suppose. So C plus 3 into 1 barabar plus 1. So C plus 3 barabar 1. So C is equal to what? 1 minus 3 means minus 2. So here C is minus 2. And you can see a CH4. So C plus 4 into 1 equal to 0. C plus 4 equal to 0. So C equal to minus 4. So here C is minus 4. C here C is minus 2. But C is there minus 4. So minus 2 to minus 4, increase or decreasing? Decreasing, no? So it is nothing but a what? Reduction. Understood? Exact example. Similarly here also will be the case. So how to remember? Whenever you see alcohol, if you see red phosphorus, if you see HI and heat, these 4 things if you see, reduction. So how to take this? Take alcohol, you take 2 moles of HI. This is very important. This is a star point. You take 2 moles of HI, then separate it, HI, 1I, I2, here H and here O, you will generate an H2O, and combine whatever things are remaining, you will generate an alkane. Similarly for this. Clear? Understood reduction of an alcohol? Next you write down. Last topic, that is reaction with ammonification, that is reaction with ammonia. So last topic can make a heading, reaction with ammonia. Okay, now see here, this is an ammonia. Okay, why I am doing so? See, if I remove one H plus here, okay, so what will I get? I will get here H plus and I will get here N H and here H, NH minus, NH2 minus. Again if I remove one H plus, so this is 2 degree amine, then 1 degree amine, then 3 degree amine. So I will go on removing one H and I will get here this way answer. So understood? So if I remove H plus from ammonia, it's not an acid. Do not understand it's an acid. Okay, just for getting the answer I am doing this. Okay, so now see this. Okay, I take alcohol and I take ammonia. Okay, but your condition is I should have a L2O3 as a catalyst and some temperature is also required. Some temperature is also required. So temperature is nearly 300 degree Celsius. Now this will get split. How? H plus, just now only I told you, and NH2 minus. So this H plus and this OH will generate what? Water, and there is formation of RNH2. This is a formation of RNH2, 1 degree amine. Yes or no? 1 degree amine. Again if I react this 1 degree amine with this ammonia, same condition, say L2O3 and 300 degrees Celsius. Okay, so what will happen? Again this H plus and this NH2 minus. Okay, so what will happen here? It will be generated near, alcohol I have to generate. Okay, so here 1 degree amine will be generated. Clear? Now if I react this 1 degree amine again with alcohol, see how I generated this alcohol. Again if I react with alcohol with the same condition provided here, so what I will form? See, again this will get split into R, NH minus and H plus. Understood, no? From NH to 1 more H I will get, so I will get as H plus. So remaining is what? Rn out of 2H, 1H is removed, so RNH minus. And here I will split at R plus and OH minus. This I am doing only for the doing reaction. But one thing more you can see here. See, I have done here splitting of what? OH I have removed. Means I am doing here CO cleavage. See here RO cleavage is done. Means this is also an example of CO cleavage. Understood, no? So now see, this OH minus and this H plus, it will be generated to form H2O. And here what I will get? I will get here R NHR. This is nothing but 2 degree amine. Yes or no? This is 2 degree. This was 1 degree amine. This is 2 degree amine. Again I will react with alcohol with the same condition provided. So what I will often say, I will split this 2 degree amine. Now again I will split this. How I will split this? R, N, R, and from here one, see here one H will be removed as H plus. So what will be remaining? Remaining will be R, N, R minus. Here R plus and OH minus. So this OH minus and this H plus will be formed what? H2O. So here R plus will be reacted with this N. So R, N, R, and again here one R, because R plus and N minus. So this is nothing but 3 degree amine. So in this way you can do the reaction. If you take alcohol which react with ammonia in the presence of L2O3, first you will obtain 1 degree, again you react with alcohol, same condition 2 degree, same condition 3 degree. So in this way you do the reaction. Here H plus, so RNH minus, again RH minus will react with this R, so 2 degree amine. From again here H plus will be removed, so what will be generated? Rn minus R. So this Rn minus this N minus again will react with this R plus. So RnRr means 3 degree amine. Clear? You can put here lone pair everywhere. So in this way, this will be the answer. You can take one example and you can do it. Okay, so in this way you can do, here you can use 1 degree, 2 degree, 3 degree, not an issue. Okay, answer remains same. So in this way you can do the reaction of alcohol with ammonia also. Here also you can see there is a cleavage of your OH, means RO will be the cleavage, CO cleavage will take place. So this is also an example of a CO cleavage of alcohol. So take a screenshot. In the next class we will move with the phenol. Thank you.